All right, we are going to be working on lesson 2 in unit number 2 titled Learning Targets Identifying Parallel Lines. What we're going to be doing is using the angle relationships that we learned in the last lesson to decide if lines are indeed parallel. So if you need to take a minute, pause the video, go back to last lesson's notes and look over those angle relationships to help refresh your memory. All right, let's get started. As the directions say, we are using a diagram to determine which, if any, lines are parallel. We will be using the same ideas from our last lesson. All right, just to remember that parallel lines are lines that never cross each other. They never intersect. All right, so number 1 says, if alternate interior angles are congruent, then the lines are parallel. So if you're given a diagram and you see two angles that are indeed alternate interior angles and they are congruent, meaning the same measure, that proves that those lines are parallel. So letter A asks us, which, if any, lines are parallel in the diagram at the right? Well, we're starting off pretty simple because we can see, get rid of this one, we can see that there are only two angle measures given to us, these two right here. Thinking back to our definition of alternate interior angles, we said alternate being on opposite sides of the transversal, which these two are. And we said interior meaning inside two parallel lines. So we're going to right now assume that these two are parallel lines and see if it's true. Okay, so we do have two angles on the inside of two lines that are on the opposite side of the transversal. Now, in order for them to definitely be alternate interior angles, they have to be congruent. They have to be the same measure, which they are. So what does that tell us? That tells us that line N and line M are parallel. They will never cross. So we can indicate N is parallel to M. Okay, that's for parallel lines, a symbol right here. And we can say, we need to give a reason. We'll say because alternate interior angles are congruent. And I am abbreviating here. This symbol right here, if you have not seen it before, once again, remember that means congruent. Okay, so let's take a look. Letter B says, which, if any, lines are parallel in the diagram at the right? So as of right now, we are given three angle measures. And we want to say, do any of these angle measures indicate that there are indeed parallel lines? Well, we see these two right here. Okay, they are congruent, so that is good. And we see that they are on opposite sides of this transversal, and they're sandwiched in between two lines right here. So that tells us that they are indeed alternate interior angles. So take a minute and think, what lines can we decide are parallel? If you decided line A and B are parallel, you are correct. Okay, we can say A is parallel to B, once again because alternate interior angles are congruent. Okay, now remembering, alternate interior angles are not the only angle relationships that we've learned. Okay, we can use some of the other ones we've learned too as well, because we never know what angles are going to be identified for us. We never know what angle measures are going to be given. So example number 2 talks about our alternate exterior angles. We know that if alternate exterior angles are congruent, then our lines are parallel. Okay, alternate exterior meaning opposite sides of the transversal, outside the two parallel lines, or outside the two lines we are trying to prove parallel. So the ones we're given here are these two right here. They're on opposite sides of that line, and they are both outside lines N and M. They're outside the sandwich. So if they're congruent, it means they're alternate exterior, which means that lines N and M are parallel to each other. Okay, so we can say N is parallel to M because, and our reason this time is alternate exterior angles. They're congruent. So as we start looking at more diagrams, we just need to know to look for the angle relationships. All right, B, which if any lines are parallel in the diagram at the right? I'm going to pause the video and I want you to go ahead and try and identify a set of angles that prove that the lines are parallel. Okay, and I concluded that lines N and M are parallel because of alternate exterior angles being congruent. And as you can see right here, I traced which those alternate exterior angles are. Okay, they are both on the opposite sides of the transversal, and they're both outside the parallel lines. Now be careful, or just notice that we're not always necessarily looking, in this side. If we have two sets of lines that run through each other, we may be looking in this direction, okay? We may be looking in this direction, not always up and down. All right, let's go ahead and flip the page. Whew. Okay, let's talk about our corresponding angles. Same thing, if corresponding angles are found congruent, then the lines are parallel. Corresponding angles, if you remember, these are the two that are on the same side of that transversal, same side of that line, but they're in the opposite parallel line, meaning they're in the same corner. So here we have this in the upper left-hand corner, and this one's in the upper left-hand corner too. Okay, so they're on the same side of the transversal, and they're kind of in the same spot in each intersection. So if those two angles are congruent, that means that A, they're corresponding angles, and that also tells us the lines are congruent. So we're going to conclude that line N and M are parallel. We'll say because corresponding angles are congruent. All right, go ahead, look down here. Take a second, pause the video, look for the corresponding angles that are going to show that lines are parallel and decide which two lines, if any, are indeed parallel. I will do the same. Okay, and here we go. So I found the line N was parallel to M because I found these two to be corresponding angles. They're on the same side of this transversal line, line A, and they're in the same location at each intersection. Okay, they're both in that right-hand corner. All right, and since those two angles are the same measure, they're congruent, which means that they are corresponding, which means that N and M are parallel to each other. So even if I had two angles identified here, if I said this was 130 degrees, they would not be corresponding angles because they're different measures. So keep in mind, we're not just looking for numbers, we're looking for the specific angle relationships, and we're looking for those angles to actually be congruent. Okay, let's take a look at one more. So now we're done with our congruent angle relationships, the alternate interior, the alternate exterior, the corresponding. Let's take a look at our consecutive interior angles. And if you remember, when we learned about consecutive interior angles, we said that if the lines are parallel, those two angles will add up to 180 degrees. So now we're working backwards, and we're going to say, well, if we see two angles that are consecutive interior that add up to 180, that means the lines are parallel. Okay, so we're just working backwards from yesterday's concept. So consecutive interior angles right here. Angles on the same side of the transversal, and they're both sandwiched in between the lines. Okay, those two do indeed add up to 180. 140 plus 40 is 180 degrees. So that means they're supplementary, which means that lines N and M are parallel. So we can say they're parallel because, and our reason this time is consecutive interior angles are supplementary. That's an angle symbol. Okay, so once again, they're parallel because those angles, consecutive interior angles, are supplementary. All right, pause the video, see if you can identify which pair is it consecutive interior angles and what lines then are parallel. Okay, it will be lines A and B. So what you had to decide was what two angles were supplementary, which two add up to 180 degrees. It's these two right here, right? Because 126 plus 44 is only 170. So you just got to be careful to make sure they do add up. Now, before we go on, if these two angles were not here, let's say those two didn't exist, just ignore them for right now. If you were just given 126 and 44, you could not prove lines parallel. Why? Well, when you add them together, they're 170 degrees, so that would not give you enough information. They would not be supplementary, therefore the lines would not be parallel. However, lucky for us, that's not the case. Just wanted you to see that. These two right here add up to 180 degrees. So the next thing you had to do was decide, well, which two lines does that indicate, meaning they're parallel? Okay, well, it tells us that lines A and B are parallel to each other. This one plus this one, they are sandwiched together next to lines A and B. Okay, see them next to A and B. They're parallel. They add up to 180, they're supplementary. Now wait a minute, does anybody notice another set of lines that are parallel? We can also indicate based on the numbers we're given that N and M are parallel because we see these two supplementary angles, 126 and 54. Okay, so these two are also consecutive interior angles and they are supplementary. Can't see my 54 anymore, but 54 plus 126 is 180. So since those two are sandwiched in between a set of lines and they add up to 180, we could also conclude that M and N are parallel. For the same reason, consecutive interior angles supplementary. And it's okay to abbreviate. These words get long after writing them for a while. Just make sure we know what you are talking about. Okay, so let's wrap it up. What we did today was we kind of did a reverse from the other day. Yesterday, we looked at lines and we told you they're parallel. And we said when lines are parallel, special angle relationships are formed. We have our alternate interiors, our alternate exteriors, our correspondings, consecutive interiors being supplementary, etc. Okay, so what we did today is we worked the other way. We said, well, where you're given lines, you need to decide if they're parallel. How are you going to decide that? Just looking at it and say they look parallel is not good enough. We need proof. The proof is in the angle relationships. So you have to look at the angles you're given and decide, do they create any relationship? Are they corresponding? Are they alternate interiors? Are they alternate exteriors? Are they consecutive interior angles? Okay, so you need to look at the angles and decide if a relationship exists. If they do, you can show that lines are indeed parallel. Let's finish up with a tad bit of practice. Okay, so you're given this diagram. Your directions say what lines must be parallel if each of the following statements are true. Now be careful. Some of them are true, but you cannot conclude any information from that. So just be careful when answering these questions. All right, please go ahead, pause the video, try it on your own. So you're just deciding which lines are parallel. I will do that as well. When you're ready, press play and check out your answers. All right, take a look. So if I know that angle 1 and angle 9 are congruent, 1 and 9, those two are what type of angles? Corresponding. Okay, same side of the transversal, same location. They're corresponding angles. And if they're congruent and they're corresponding, that means that lines P and Q are parallel. Okay, line P and Q. If I'm told that 5 and 4 are congruent, that's these two right here. Those two are alternate interior angles. They are sandwiched in between two lines on opposite sides of the transversal. And if they're congruent, they're alternate interiors, which would make, which lines are they sandwiched in between? R and S. If angle 3 and 5 are congruent, okay? 3 and 5. Those are consecutive interior angles. Oops, sorry. My mistake. 13 and 5. I colored the wrong one. Go erase that. 13 and 5. That makes more sense. If 13 and 5 are congruent, okay, those are corresponding angles. They are corresponding angles, meaning they are congruent. They're in the same side of the transversal, same location. So we can conclude then that P and Q, okay, because which two lines are they next to? P and Q. That means they're parallel. All right, if the measure of angle 4 plus measure of angle 11 equals 180, okay, 4 and 11. Here, I was trying to rush this one. Here are our consecutive interior angles. If they add up to 180, that means they're supplementary. So if they're supplementary, that means that they, once again, are consecutive interior angles. So we can conclude that P and Q, because those are the two lines that they form the angles with. Okay, so P and Q are our parallels there. All right, now, if we tell you the last two are true, they may be true, but they may not give us enough information to make a conclusion about parallel lines. So I'm going to erase what I have up here so far, just so we can get a better look. Okay, and I'm saying that 2 and 15 add up to 180. So I've got 2. Oops, sorry, I'm on my eraser still. I've got 2 and I've got 15. We're saying they add up to 180 degrees, but that does not give us enough information to decide if any angles are any lines are parallel. Okay, they are not consecutive interior angles. They're not alternate exteriors. They're nothing. Okay, in order for them to tell us information when they add up to 180, they have to be next to each other inside, which is not true. Okay, the last one is saying angle 7 and angle 6 are congruent. That is a special angle relationship, vertical angles. But are vertical angles helping us identify if the lines are parallel? No, vertical angles deal with when two lines intersect each other. The opposite angles are congruent. Okay, so yes, that may be true. They may be congruent. Well, they are, but that doesn't help us with parallel lines. Okay, go back through, replay the recording if you need to. Please bring questions to class.